Alright, so in this video, we're going to be discussing alternative ways of finding the reduced row echelon form. So here's a matrix, and let's suppose we were tasked with finding its reduced row echelon form. Now, if you saw the video for the Gauss-Jordan method, you probably start to feel a little queasy even looking at this thing. I know that I do. I certainly don't want to start, say, by dividing everything by 3's and negative 2's or 2's and 3's to get leading 1's. I could rearrange these rows a little bit, but this is going to take all day, even if you use the slickest methods possible to find this reduced row echelon form, and I just don't want to, right? And so, what you may have noticed as you found the reduced row echelon forms in E2 was that the process of going through that method to some extent feels mechanical. And whenever there's a process that feels mechanical, it should be done by machines. And so this video, we're going to use technology to find the reduced row echelon forms of these matrices. Now, just taking a look at what we have here. What we have here is a 5 by 3 matrix, 5 rows, 3 columns. So if you follow along in the text, you should see that there is a instructions for how to enter a matrix into Sage. Sage is a computer algebra system that's free and online that can greatly simplify this sort of thing for us. So what we want to do here is enter in our 5 rows. So my first row is 3 minus 10. So I need a minus here. Minus 10, 0. Minus 2, 7, 0. And let me add in the rest of my rows. 1, 2, 0. 2, negative 7, 0. 3, minus 9, 0. Alright? And I can go ahead and evaluate this cell and compare to, let's go ahead and shrink this down a bit and put these side by side just to make sure that I'm looking at the same sort of things here. Now we have our rows here, our 3 columns, sorry, 3 minus 2, 1, 2, 3, negative 10, 7, 2, negative 7, negative 9, and 0. Alright, so let me blow this back up and move back over here. So if I want its reduced row echelon form, I can go ahead and just type in A.RREF, which stands for reduced row echelon form, hit it with that, and boom, that's my reduced row echelon form. Beautiful, right? So if I go back here and I ask, hey, what is RREF of that? Well, it's 1, 1, 0, 0, 0, 0, and then 3 rows of zeros afterwards. Alright. Hopefully that was instructive on how to use Sage to do this. Now, since more recently, Desmos has put out a matrix calculator as well, and we can use this also to do these computations. So here I have a 5 row, 3 column matrix, and let's go ahead and throw in our entries: 3, negative 10, 0, minus 2, 7, 0, 1, 2, 0, 2, negative 7, 0, 3, negative 9, 0. If I hit enter, that records the matrix. And if I take its reduced row echelon form, I get the same thing, right? 1 and 1 and zeros everywhere else. Exactly what we found here. So while it's important to be able to do the Gauss-Jordan method and understand where the reduced row echelon forms are coming from, it really is much easier in practice to use technology to find these forms. All right. Thank you very much.